Okay guys, we are doing adding and subtracting rational expressions today. Please make sure that you get the half sheet warm-up to review adding and subtracting fractions. So you guys will be able to add and subtract rational expressions, kind of like what we did with multiplying and dividing. We're still going to have to factor, but now we are going to have to figure out common denominators. Okay, so here is our warm-up. Please make sure that you pick this up at the front of the room, or please make sure that you get one. It is a half sheet. So we first need to find the least common multiple, or the LCM, between the two numbers. So when you're looking at the number 8 and 4, the least common multiple is going to be the largest number between the two, and or it might be larger than that. So between 8 and 4, I can do 8 times 1 to get to 8, and then 4 times 2 would give me 8. So my, let me get my pen here. So my LCM for this one is going to be 8. So that means that the first one, 3 over 8, I don't have to adjust that denominator, but I do need to make this other fraction have a denominator of 8 as well. That's what we call the LCD, or the least common denominator. So to get from 4 to 8, we need to multiply by 2, and whatever we do to the bottom, we have to do to the top. So I'm going to have my new equation is going to be 3 over 8 minus 6 over 8. And now you would just subtract or add on the top. You don't touch the bottom, you just subtract or add on the top. So 3 minus 6 is negative 3, and then over 8, and that's your answer. The denominator stays the same, and your final answer does not change to 16. So then for the next one, between 5 and 7, the LCD, or the least common multiple of 5 and 7, we have 5, 10, 15, 20, 25, 30, 35. The only number that is a multiple of 7 that is common with 5 would be 35. So both of these need to have 35 in the denominator. So 5 times 7 will give me 35, and then 7 times 5 will give me 35. So my new expression here, 7 times 3 is 21 over 35. 1 times 5 is 5 over 35, and then I would add across. So 21 plus 5 is 26, and then I get 26 over 35. And I could not reduce this one or this one, so it just stays the same. Now you're getting into your exponents and variables here. So what I want to do is figure out what my LCD or LCM is, whatever you want to call it. So between 7 and 5, we already did that with the second one. So my number there, my least common multiple, would be 35. But then for the exponents and the variables, you're always looking at your bigger exponent of the two. So I have a and a squared. I can't take one of the a's away here to get to a. So I could add an a to this one in order to get to a squared. So 35 a squared is going to be my LCM, or my least common denominator. So I need to multiply the first one from 7 to 35, that's 5. From a to a squared, I need to multiply by a. So I'm going to multiply by 5a on the top and the bottom. I already have a squared in the second portion, but I need to get to 35, so I'm going to have to multiply the top and the bottom by 7. You need to distribute, so make sure that you do that. 5a times 2 is 10a over 35a squared. 4 times 7 is 28, and then over 35a squared. And if you want to skip this step here, you could just go straight to your end step, which is 10a plus 28 over 35a squared. So if you want to go from here all the way to here in one step, that's perfectly fine. There is nothing that I can simplify that with, like 10, 28, and 35 can all not be divided by the same number. There's no common multiple there, so I'm just going to leave it as it is. So go ahead and try these next ones. I'm going to go ahead and run through them. So pause it and try them. Give yourself a couple minutes to try them. Okay, so for number 1, between the number 10 and 5, the LCD would be 10. So my first fraction is already at 10. I need to multiply the second fraction by 2. So I'm going to have 3 over 10 minus 2 over 10. And then again, you're just going to work with the top. So 3 minus 2 is 1. So my answer is 1 over 10. Can't reduce that any further. For number 2, 16 and 6. So between the numbers 16 and 6, well, 16 times 2 is 32. 32 is not a multiple of 6. 6 times 3 is 48. 48 is a multiple of 6, so my LCD is going to be 48. I'm going to multiply 16 by 3 and then 6 by 8 to get to 48. And then I need to distribute. So 3 times 7 is 21, 3 times 16 is 48, 5 times 8 is 40, 6 times 8 is 48. And then you're going to add 21 plus 40 to get 61 over 48. You cannot reduce that. You can leave it as an improper fraction, or you could do like, I don't know what the answer would be, like 1 in, you know, that would be 1 in 19, no. 1, yeah, maybe that, maybe 1 in 17 48ths or something like that. I would just leave it as an improper fraction. For number 3, so multiples of 12 would be 12, then 24. 24 is a multiple of 8, so my LCD is going to be 24. In order to get from 12 to 24, I need to multiply by 2. In order to get from 8 to 24, I need to multiply by 3. So I'm going to have negative 14 over 24 plus negative 9 over 24. You'll add those two together on the top, and you get negative 23 over 24 as your final answer, and you cannot simplify that. The next one, we throw in variables for these last 3. So remember, you need to include your variables there. So I have 2x and then 6. I cannot just get rid of that x, so I'm going to have to bring x into the LCD, and then between the numbers 2 and 6, the least common multiple would be 6, because I can easily multiply 2 by 3 to get to 6, and then my second fraction is missing an x. You're looking for the missing piece. You need to multiply whatever is missing in order to get your LCD. 3 times 3 is 9 over 6x, and then 5 times x is 5x over 6x. And then just put that into one single fraction. You're just going to add on the top, and you cannot simplify that, so just leave it as 9 plus 5x over 6x. For number 5, both of them have a t, so that's going to stay part of our LCD. The number 4 and the number 20. 20 is a multiple of 4, so my LCD is going to be 20t. I need a 5 here. I don't need anything with the second fraction because it's already at 20t. So it's going to be 15 over 20t minus 7 over 20t. 5 minus 7 is 8 over 20t. Now this one, both of these can be simplified by dividing the top and the bottom by 4. If I divide 8 by 4, I get 2. If I divide 20 by 4, I get 5, and then the t just comes down. So 2 over 5t would be your answer. The last one, so my LCD between 9 and 5, the common multiple between those two would be 45. And then I cannot just get rid of my a's. So the highest exponent is a to the third, so that's what I need to use for my variable here. And it's not letting me, okay, there you go. 45 a to the third. So for the first fraction, I'm going to multiply by 5. 9 times 5 gives me 45. Then for the second one, I need to multiply by 9, but I also need to multiply by a squared to get to that a to the third. 5 times 5 is 25. 4 times 9 is 36, and then a squared over 45a to the, oops, that shouldn't be 9a to the third, it should be 45a to the third. And then 45a to the third. So then just combine on the top. You cannot simplify this, so just leave it as 25 plus 36a squared over 45a to the third, and that's your final answer. Okay, once you finish this, make sure to go up and get the notes. It should say 8.2, adding and subtracting rational expressions, and we are going to get right into it. So our first section is finding the least common multiple for monomials. So between, well, the steps would be to find the LCM of the number. So what number is the least common multiple of the two? And then for variables, you're using the highest exponent. So we're going to use this method to do our LCD later on. So between the number 8 and 12, I can do, so for 8, I have 8, then 16, then 24. I know that 12 has a multiple of 24. So my LCM number is going to be 24. Then for my x's, I have x and then x to the fifth. It's going to be the highest exponent always. Then for the y's, I have y to the third and y squared. So I'm going to use y to the third because that's the higher exponent. So my LCM is this. I need to get from my two terms to get to the 24, x to the fifth and the y to the third. So 8 times what would give me 24? I'd need a 3 there, 8 times 3. X times what would give me x to the fifth, which would be x to the fourth. Remember, you add your exponents. And then I'm just going to leave my y because it's already at y to the third. For 12, I would need to do 12 times 2 to get to 24. My x to the fifth is already there, so I don't need to change that. And then I need one more y in order to get my LCM. Okay, for the next one, so you're looking at 6 and 12. My LCM here, so 12 is a multiple of 6. Remember when I said it's going to be your highest number or bigger than that? So my LCM here would be 12, and then my a's, my highest exponent that I have for a is to the fifth. My highest exponent that I have for b is just b. So to get from 6 to 12, I need to multiply by 2. I don't need to do anything with the a's, but I do need a b, so I'm going to have to multiply by 2b. For the next one, my LCM is already at 12. I need 2 more a's, and I have a b, so I don't need to do anything there. Go ahead and pause it and take a minute to do number 3. Your LCM here between 6 and 10. 6 times, so think of the multiples of 10 that are multiples of 6. So we have 30 and we have 60. So I'm going to use 30 because it's smaller. You want the least common multiple possible. Between the x's, my highest exponent that I have for x is x squared. I also have a y to the third, and I have a z. You need to use all of the variables. You can't just skip one. So to get from 6 to 30, I need to multiply by 5. I already have my x squared, and I already have my z. So I need to multiply by y to the third to get to that LCM. The last one, to get from 10 to 30, I need to multiply by 3. I need one more x, and I also need a z to match my LCM. Okay, so then finding the LCM for polynomials. This is going to be the same type of approach, except we are going to have to factor them first and then get them to match. So x plus 2 I can't factor. You might want to take out your half sheet here to help you. So all of these you're going to either do, guess and check or Xbox, and a difference of squares, you're not going to have to do grouping. Some of these you might have to do GCF, so just realize you're not going to have to do grouping. So x plus 2 I can't do anything with, but x squared minus 4x minus 12, x times x gives me x squared. I'd need a 3 times 4 or a 6 times 2 to get to 12. Is that not erasing? Okay. So x, I'm going to do 6 and 2. Because 6 plus 2, or negative 6 plus 2, negative 2 plus 6 would get me closer to negative 4. Because it's a negative 4, I'm going to need a negative 6 and a positive 2. So this tells me that my LCM, or LCD, LCM because we're not doing denominator right now, LCM is, both of them have an x plus 2, so that's going to be part of it. And then this one has this x minus 6, so I can't just get rid of that. I'm going to need to use that. So I would need to multiply x plus 2 by x minus 6 in order to get my LCM. This one is perfectly fine. It already has both parts of the LCM. For number 5, x plus 5 squared, so we have 2x plus 5s. And then x squared plus 7x plus 10. To get to x squared, I need x and x. To get to 10, I could do 10 and 1 or 5 and 2. 5 and 2 is going to put me closer to 7, and because everything's positive in that trinomial, both of those need to be positive. Okay, so I have an x plus 5 that matches, so my LCM is x plus 5. But then I also have this extra x plus 5, so that needs to be part of my LCM. And I also need this x plus 2, okay? So like we did when we were canceling out fractions, you can't double dip. So because I have 3 x plus 5s, I can't just say, okay, I'm going to need 1 x plus 5. You have to, so the ones that are partners, so x plus 5 and x plus 5 in both, counts as one LCM, and then you have to add in the other ones. So for this one, I'm going to need to multiply this one by x plus 2, and I'm going to need to multiply this one by x plus 5 in order to get to my LCM. Go ahead and take a second to do the you-do, factor it, and then decide what your least common multiple is, and then decide what you need to multiply by. So this one is going to be, I need an x and an x. To get to 12, I can do 4 and 3, and 4 and 3 is going to put me awfully close to 7. If I do both of them plus, it's going to give me 7. For the next one, I need x and x. To get to 15, the easiest, or the closest way to 2 would be a 5 and a 3. Because it's a negative 2, I'm going to need a negative 5 and a positive 3. So again, my LCM, make sure you look at the ones that match. So x plus 3 is in both of them, so that's going to be part of my LCM. I have x plus 4 here, so that needs to be part of my LCM. And then I also have x minus 5, so those are different, so I need to include that as well. My second function here is missing an x plus 4. And my other one is missing an x minus 5. So I would need to multiply those by that to get the LCM. Okay, what I'm going to do here is I'm going to do 7, 8, 9, and 10. You guys are going to do the you-dos. And then you will have some time to do the you-dos. I'm not going to include them in my PowerPoint so that you can actually try them on your own. So I'll do 7, 8, 9, and 10, and then I'll jump down to the subtracting and do 13, 14, 15, and 16, and then you guys will try the you-dos, and you can check your answers with my key up front. So just ask for the key and you can check your answers with that, okay? So for adding and subtracting, you're always going to need common denominators. So right now, these two have the same denominator, so my LCD is just going to be x plus 2. The good news is I don't have to do anything extra here. Both of these already have the common denominator, So I can just go ahead and make this one big fraction. So x squared plus 6x plus 2x minus 5 over x plus 2. Okay, remember we're just adding across, we're not changing the denominator at all. So we can combine like terms here, the positive 6x and the positive 2x, to get x squared plus 8x minus 5 over x plus 2. Now you might think, oh, I can factor that top. I'll tell you right now that the majority of these questions that we do are not going to factor any further. So combine your like terms and then get your answer. If there is one that factors, I will tell you about that, especially on the test. So my answer here is just x squared plus 8x minus 5. You might think this is really easy. It might seem super easy right now, but there are a couple other things that come into play here. So on to the next one. Okay, so now we have 4x to the 5th and 6x squared. Okay, so this is where we get a little tricky. So our LCD here, we need to think about the common multiple between 4 and 6. 4 times 2 is 8. 4 times 3 is 12. 6 times 2 is 12. So my number is going to be 12. And then my x's are always going to be the highest exponent. So my LCD is 12x to the 5th. So my goal here is to get 12x to the 5th in the bottom. Okay. I need to multiply both of these by something in order to get to 12x to the 5th. So to get from 4 to 12, I need to multiply by 3. My x to the 5th is already there. I don't need to change that. To get from 6 to 12, I need to multiply by 2. And then to get from x squared to x to the 5th, I need x to the 3rd. Okay, so then on top, now this is the trickier part. You need to make sure that you distribute. So 3 times x plus 4 plus 2x to the 3rd times 3x minus 2. Now you can do this all in one step and skip the step that I'm doing right now if you want, but I would suggest writing it down for at least the notes portion here so that you understand where I got my answers. So I need to do 3 times x, which is 3x, 3 times 4, which is 12, 2x to the 3rd times 3x, which is 6x to the 4th, and then 2x to the 3rd times negative 2, which is negative 6x to the 3rd. And that's all over 12x to the 5th. So if you want, you could go from this step here directly to this step if you choose to. So my last step then would be to rewrite it in descending order. So 6x to the 4th minus 6x to the 3rd plus 3x plus 12 over 12x to the 5th. Did I screw something up here? Let me make sure. Let's see. Oh, that's because I messed this up here. This should be 4x to the 3rd, not 6. 4x to the 3rd, 4x to the 3rd. Okay, so none of those have a common number that they can be divided by, so this is my final answer. Okay, now we get to 9 and 10 where we need to factor. So x plus 2 I can't factor, but x squared plus 5x plus 6 I can factor. So I'd get x and x to get to x squared. And then the ways to get to 6 are 3 times 2 or 6 times 1. Which one would put me closer to adding to 5? It would be 3 and 2 because all of these are positive. Okay, so now looking at our LCD. So I have x plus 2 and x plus 2, so those two match. That's our first part of our LCD. Then I have the x plus 3. I can't get rid of that, so I need to put that as my LCD as well. So I'm going to multiply this one by x plus 3 over x plus 3. And then my second one I don't need to do anything to. So write it as one big fraction, x times x plus 3 plus 4x minus 2 over x plus 2 times x plus 3. And leave it expanded like that. x times x is x squared, x times 3x is 3x, and then rewrite the rest of your pieces. And then combine like terms for your last step. So you'd have x squared plus 7x minus 2 over x plus 2 times x plus 3. And there's no way that you can factor that top part trinomial, so just leave it that way. Okay, if for any reason you need to, pause the video, please go ahead and do that so that you can get this written down. Okay, so for number 10, I need to factor both of these. So for the first one, both of these are trinomials, so I'm going to have x and x because these are x squared. To get to negative 3 and add to a negative 2, I need negative 3 and positive 1. For the next one, to get to a positive 12 but add to a negative 7, I need two negatives, negative 4 and negative 3. So my LCD here, x minus 3's match up, so that's one piece. Then I have two other different ones, so I need to have x minus 4, I need to have x plus 1. Okay, so this first one is missing an x minus 4, and my second one is missing an x plus 1. So look at your LCD to see what they're missing. So I'm going to have 10 parentheses x minus 4 plus 5x plus 2 times x plus 1. And if you need to, I would put these in like brackets because you need to distribute that stuff first. And it's all over x minus 3 times x minus 4 times x plus 1. So 10 times x is 10x. 10 times negative 4 is negative 40. And then it's going to be plus 5x times x is 5x squared. 5x times 1 is 5x. 2 times x is 2x. And then 2 times 1 is 2. All over x minus 3 times x minus 4 times x plus 1. Okay, so then combine like terms. So I have 5x squared, that's going to come down. Then I have 10x, 5x, and 2x. So 10 plus 5 plus 2 would give me 17x. And then I have negative 40 and positive 2, which would be negative 38, all over x minus 3 times x minus 4 times x plus 1. And that is your final answer. Okay, so you can either pause it right now, do the you-do, and then go ahead and check up front, or you can just listen to the 4 division or subtraction problems and then do the you-dos all at once. Okay, so I'm going to skip 11 and 12, and then you'll go and check your answers up front. Okay, so subtracting is basically the same. We still need to find our LCD, but our new step is to and I totally just spelled that wrong. Distribute the negative or the minus. Okay, so that being said, both of these have the same LCD, so I don't need to do anything extra here. So what I'm going to do, now be mindful of what I am doing here. I'm going to write 2x plus 3, but then I'm going to subtract the whole thing of 5x squared minus 4x plus 10. Do not forget those parentheses because you need to distribute the negative. So I have 2x plus 3 is going to come down. Then I have minus 5x, minus 5x squared plus 4x minus 10. And that is all over 3x. So then we can combine our like terms. I have negative 5x squared, and then 2x and 4x can combine to make 6x. And then 3 and negative 10 can combine to make negative 7 over 3x. You cannot simplify it any further. That is it. Okay, so then for number 14, okay, we have 5x to the 4th and 3x to the 7th. So my LCD, between 5 and 13, the least common multiple is 15. And then for the exponents, I have to do x to the 7th because it has to be the highest exponent. Okay, so that being said, to get from 5 to 15, I need to multiply by 3. To get from x to the 4th to x to the 7th, I need to multiply by x to the 3rd. The next one, to get from 3 to 15, I need to multiply by 5, and then I just leave it as that because I already have x to the 7th. So again, you can just distribute it if you want all in one step. I write it down because it's easier that way. All over 15x to the 7th. So 3x to the 3rd times x would be 3x to the 4th. 3x to the 3rd times 4 would be 12x to the 3rd, and then minus 50 over 15x to the 7th. There is no number that all of those can be divided by, so I'm going to leave it like that. Okay, then on to 15. So, between 2x plus 5 and 4x plus 3. They don't have an they don't have a common, a GCF or anything, so I'm just going to use both of those because I can't simplify it. I need both of those, so 2x plus 5 and 4x plus 3. So that means this first one needs 4x plus 3. And my second one needs 2x plus 5. Okay, so then I'm going to have 4x plus 3 times 3x minus 1. And again, you might want to use brackets there to show that you need to distribute that. And then I'm going to subtract. Now this is where it gets a little tricky, and be careful. 2x minus 5 times 2x plus 5. All over 2x plus 5 times 4x plus 3. Okay, so 4x times 3x would be 12x squared. 4x times negative 1 is negative 4x. 3 times 3x is positive 9x. And then 3 times negative 1 is negative 3. Then I'm going to have to subtract this whole entire piece here. So 2x times 2x is 4x squared. 2x times 5 is 10x. Negative 5 times 2x is negative 10x. And then negative 5 times 5 is negative 25. All over 2x plus 5 times 4x plus 3. Okay, so we'll bring down our 12x squared minus 4. Well, I can combine these two. It would be plus 5x minus 3 minus 4x squared. These two actually in the middle are going to cancel, and then negative times a negative 25 would be positive 25. All over 2x plus 5 times 4x plus 3. And then I can combine like terms. So 12x squared and negative 4x would be 8x squared plus 5x, and then negative 3 plus 25 would be positive 22, all over 2x plus 5 times 4x plus 3. And then the last one, so we need to factor. So we would have, let's see, x squared minus 25 is x minus 5, x plus 5. And then this one would be x minus 5, x minus 2. So that means my LCD needs, they both have x minus 5, so that's part of it. Then I need an x plus 5, and I need an x minus 2. So the first fraction is missing the x minus 2. The second fraction is missing the x plus 5. So I'm going to have 6x times x minus 2 minus x plus 8 times x plus 5 over x minus 5 times x plus 5 times x minus 2. 6x times x is 6x squared. 6x times negative 2 is negative 12x. Then I'm going to subtract this whole thing. X times x is x squared. X times 5 is 5x. 8 times x is 8x. 8 times 5 is 40. And then it's all over the LCD. Then I need to distribute. So, and I can combine these two to make 13x. So 6x squared minus 12x minus x squared minus 13x minus 40 all over x minus 5, x plus 5, and x minus 2. Combine your like terms, so 6x minus x squared would be 5x squared. Negative 12x and negative 13x is negative 25x, and then minus 40. All over x minus 5 times x plus 5 times x minus 2. Okay, then I want you to do the 2 you try, or actually the 4 you do problems, and then check your answers with mine up front.